is Avery, and today I'm going to be showing you guys how to make a simple binary search application in Shell. So, for this application, we're going to be using a list that I already have pre-created, and it's like this. So it has the name in capital letters, and then it has a colon, and then it has the student's grade. So for the binary search, basically, we're going to be able to pass in a name, and it'll give it the grade. But instead of looping through just until it finds the name, it will sort out the list alphabetically. So like Anne would be towards the top, and then it will pick the very middle of the alphabetical list, and then see if that middle is the name that you're looking for. And then if it's not, it will parse the list in half, based on either if it knows that it's higher, then it will take the middle half, the top half, and it'll look in that middle. Or if it knows it's lower, it'll take the bottom half and look in that middle, and it'll just loop through and do that over and over again until you find it. So this is just going to be a simple application using binary search. So we're going to go ahead and get started. I'm going to just call it search.sh. And now the first thing I want to do is just declare it as a bash file, which is just the version of shell that we're using. And now we want to sort our list to make it so it's alphabetical. There's a really easy way to do this. Just use the program called prompt called sort. Sorry about that. And you just do list.dat, and now you want to sort it into sorted list.dat. We'll just call it that. And now we want to read for the name, so we'll just do read, and then it's going to be like this. And it's as simple as that. So now we've read in the name that the people are looking for. So now what we're going to do is to make it so it can be capital or non-capital or anything. It can find it no matter what. So to do that, we're just going to make the name lowercase. So to do that, you just do n equals, and then in these brackets, you'll just do n comma comma. And that makes everything in the name lowercase no matter what you gave in. So now we want to make an array using the list that we got, the sorted list. And the array is going to have a name array, it's going to have a grade array, and then it's also going to have a lowercase name array. So what it's going to do is just you look through the lowercase name array using the lowercase given name, and then once it finds it, it can print out the capitalized name using just the regular name array, and then it can say its grade based on what point it is. So to do that, we're also going to keep track of how long the list is. So we're just going to add a number every single time we loop through the list. So we'll just do the length of the list. We'll set it to total, and we'll set that to 1. And now for the loop, it will just be while read line. So now line is just going to be the name of the variable for each single line. And then we'll close off the loop. It'll be done. And then we'll do sorted list.dat. So now this right here is what it's looping through. And every single line, the variable is going to be called line. So now the first array is just going to be called name, and it'll be total, like that. And then we're going to set that equal to the variable of line, and then it will be two percentage signs, and then it'll be a colon, and then an asterisk. So basically what this is doing is getting the name, and then so the name is going to be in front of the colon because the list had a colon. So everything after the colon is getting blocked off, but the name is going to be the front, and that's what the that's what the percentage signs mean. So it's going to get the name from the very beginning. And remember that this is the sorted list, so it's all going to be alphabetical. Now we'll just do the same thing for the lowercase name. We'll just do LC name, and then we'll just put total. So total is the pointer that it's at, so as you know, it starts off at 1. And to do that, we can just do the same thing we did up here. So I'll just do, but we'll do it with this point right here. So it'll just be name, total, and then comma comma. Now for the grade, it's going to be pretty similar that we did with the name. It'll just be grade total equals. And now for this one, instead of using the percentages, it'll be hashes. So it'll be hash, and then like that. And that'll basically just make it so it looks afterwards. Or actually, the asterisk is up here. And then you want to put brackets around this as well. So what this is doing is basically just getting, for the name, it's going to get the stuff in front. That's what the percentages are going to mean. And the hashes are getting everything that's at the tail of this, which is what the grade is. So now that we've sorted through the list and then split it up into arrays, I'm going to go ahead and actually do the binary search. And then right here, I think, looks like there's a problem right here, or at least the way it's highlighted. Let's go ahead and put quotes around that. So now we're going to create our function. I'll just put a space right here. And the function will just be called binary search. So now when you pass in the binary search, you want to give it the size of the list that you're looking through. So there's going to be two arguments. The first one will be the first number, and the last one will be the last number. So those are the size of our list. So we'll just do local first number, and that'll be set to the first argument. So when you call binary search, the first argument will be set to this local variable. It's only inside this function, and will be set to first number. And then you'll do the same for last number, and that'll be just the second argument. So now in here, we're going to figure out what the size in the middle of the list is. So let's create this variable called middle, and then we want to figure out its size. So to do that, the first thing we want to do is we can do the last number minus the first number. And now that we've done that, we want to divide that by 2. And then I'll just close off some things that are going to be closed off right here. And then, so it's going to be the first number plus. So basically, what this is going to do is just get the middle distance between this one. So say this one's 5, or I'll say this one's like 1 and this one's 10. It's not going to have an exact middle, but it can calculate it to 5, so it knows that's the middle point, and it'll just look in it. Or if it was 1 and 3, it would find 2. I just want to double check this to make sure this is the right math. Okay, yeah, that looks right. So now that we have the middle number, we can go ahead and look in the middle of the array and compare it. So let's make an if statement, and then in the if statement, it will just ask if the lowercase name at middle, and then we'll go ahead and put quotes around this, and we'll go and put the bracket around there too. But you just want to see if that equals the name, so we'll just do equals, and so if that equals, as simple as that. That's the first. That means the middle name is what it is. Now we can just print out the grade for the middle name. So to do that, we'll just do echo $, and then brackets. It'll be name. So now we're getting that capitalized name, middle, and then we'll say, so the capitalized name's grade is, and then it'll be another pointer from the array. It'll be grade, and then it'll be middle. And then basically it'll just print out the grade that's equivalent in the same point as the one with the capitalized name. But if that's not what it is, if it hasn't found this, then we need to say what to do next. So one other if statement is if the middle is equal to the first or the last number. Because if it is, that means it's reached the end, and if it hasn't found it, we need to say that it's not in the list. So I'll go ahead and check for that by doing if last number is equal to middle, or if first number is equal to middle. Then, so if this is true, then we'll just say echo, and then I'm going to say n is not in the list. So now we want to figure out if it isn't equal, but it's not the middle. We need to figure out a way to parse it. So like I said earlier, if it's not the middle, you have to figure out to pass in the above half or the below half. So to do that, we're just going to check if, say that there's a list from A to Z, and then if you give it K, and then the middle is an M, it's going to know that K is less than M. So it's able to do like the math for it, but alphabetically. So it knows K comes before M. So you can ask if it's supposed to be after or before. And then based on that, you can split the list through another divider by going above the first half or below the first half. So to do that, we're just going to make another LF statement. And in here, we're just going to be doing n is greater than, and close it off, if it's greater than the last lower count name of middle. So if it's greater than it, that means that the first number should be the middle. So what I mean is, if you have the middle is an M, and you're looking for a name that starts with an O, O is going to be greater than M. So the middle doesn't need to be M. They know that they don't need to search anything before that, so we'll just set the first name to the middle, and that's splitting it in half. So to do that, we'll just do first number equals middle. And now we'll just do the opposite of this. LF, and then it will be if it's greater than the lowercase name of middle, then it will be the last number equals middle. And now we'll go ahead and end this if statement. So now if it has actually gone through everything, it's going to want to do another binary search. So the binary search is basically just going to call the function in itself. So we'll just do binary search, and then it'll be the first number, and then the last number. So now here at the bottom, we'll just want to call this function for the first time. So we binary search 1, and then as you recall, we counted the total, so the total will be 1. I mean, right here, and actually right in here we need to count the total. So we'll just do total plus plus. So that's pretty simple. So now we go ahead and make it to this program can be ran. So let's do chmod u plus search, and now I'll clear that and we'll run the program. So how is one of the names. Okay, we got an error, line 22. Let's go ahead and just check that. It's with lowercase middle. Okay. Is that this line? Echo in. Here, I need to double check to see which one that was. Oh wait. If lowercase middle equals n, then your unexpected token then. Okay, so just right up here. So the unexpected then, that could, why is that? these spaces right there. Let's just try that again. Nope, it's the same thing. Okay, syntax error near unexpected token then. Okay, I know what the problem is. So we can go ahead and leave these spaces in, but we also need a space in between these. And then also these last two functions or if statements need 2 brackets. And also if it finishes, either it can't find it or if it does find it, we need to exit. So this one will just do exit 0 and this one will be exit 1. So those are just the 2 arguments. We'll go ahead and try that out again. How? Okay. Not valid. So it's looping through it. Too many arguments. Here, let's just run that. Okay, sorry. I was trying to cancel it at the last moment. Okay. Just want to see one of the first statements. I guess it doesn't matter. 25, 17, 18. Not a valid identifier. Let's go ahead and open it up in gedit so I can see the lines. So 25. So in this section, there's too many arguments. I think it's the way it's set up. So, oh, well, right there. It's supposed to be middle. Here, let's just see what that fixes. Nope, too many arguments still. 17, local, not a valid identifier. 17, not a valid. Okay. Oh, here, I don't know, let's get rid of these spaces. Oh, okay, still 26, too many arguments. So for this one, let's just go ahead and, I'll open it back up in the same way or in Nano like we had before. So for this line, what we're going to want to do is just last name equals the middle. Okay, that's also misspelled. Okay, that's still not it though. Here, let's just go ahead and split this into two different statements. So it'll just be elif first num equals middle, then echo and is not in the list. Exit 1. How is not in the list? Okay, let's okay, line 19 and 26. Let's go ahead and hold to check what those are. 19. Oh, I don't know how that happened. Oh, that's why. That's the way I was saving it. Okay, 19. And then 26. Well, I guess that might have changed which one this 26 was. House grade is B. Okay. Before we check that, we'll just make sure that's right. So cat list.dat house B. And then also, if you do cat sorted list.dat, you can see it's alphabetical now. But, so yeah, house B. Let's check out that error. Urinary operator expected. It's line 28. So right here, so now to solve this problem, we're just going to put quotes around these. No, let's just try that. How? Sweet, okay. Which is that? I got the sorted list. Sorted. So now, say we did like Frank, it would find them much faster than if we did like Sydney or Dean or Ivy or Justin. It'll find them. So basically, but it's pretty simple. It's like how the binary works. Like I said, it just splits it in half over and over again until it finds it and always checks the middle. So that's our binary search. As always, the code will be in the description. This list will be in the description as well. If you guys are new here, feel free to subscribe. I do other random programming videos. I have like a game development tutorial series in C++ and STL2. And if this was useful for you, just go ahead and like the video. Thanks again for coming and have a great day.